designed as a retrofit for existing commercial rooftop air conditioners, DualCool uses evaporative cooling in two different ways, hence the name DualCool. Number one, it improves the efficiency of the vapor compression cycle, and two, it reduces the ventilation cooling load. Let's explain that a little further. An air conditioner cools air inside a building by blowing air across a cold coil that contains a refrigerant. When ventilation is required, air from outside is mixed in with air being recirculated within the building. The heat from the air is transferred to the refrigerant. A compressor pumps the refrigerant to another component inside the air conditioner, called the condenser, where the heat collected from the building is exhausted, or rejected, outdoors. In short, an air conditioner moves heat from inside the building to outside the building. The hotter it gets outside, the harder the compressor has to work to reject the heat. When this happens, the compressor uses more electricity and the performance of the air conditioner is reduced. One of the ways DualCool saves energy is by cooling the air around the condenser, making it easier to reject the heat to the outside. DualCool cools the air around the condenser by pumping water over a rigid evaporative media. As the warm outdoor air passes through the media, the heat of the airstream evaporates the water into the air, cooling both the air and water exiting the media. The chilled air then arrives at the condenser coil, allowing the air conditioner to operate more efficiently, as if the outdoor temperature were lower. In the process, DualCool also generates cold water. This water circulates through a water-to-air heat exchanger, located in the ventilation airstream, which cools ventilation air before it enters the rooftop unit. The water is then returned to the evaporative media on the condenser side of the DualCool. In this way, DualCool simultaneously reduces the cooling load and improves the efficiency of the vapor compression cycle. Although evaporation is used to provide these benefits, no humidity is added to the air that then enters the building. The evaporated water is rejected outdoors by the condenser fan. DualCool is effective for a range of climates and applications, but the energy savings achieved increases as outdoor temperature increases and humidity decreases. So, DualCool is particularly well suited for hot, dry climates. This video will explain one evaporative ventilation air cooler called ClimateWizard. ClimateWizard is a standalone technology that delivers 100% cooled ventilation air. It uses significantly less electricity than a standard rooftop air conditioner and adds no humidity to the building. It does this by using an indirect evaporative cooling process. Let's explain that further. The heat exchanger in the ClimateWizard is made up of a series of alternating wet channels and dry channels, which are designed to transfer heat between them. Hot outdoor air enters the dry channels of the heat exchanger through a high-efficiency fan. After air passes through the dry channels, a portion of the air is supplied to the building and the rest returns through the wet channels. This is where the evaporative cooling process takes place. The evaporative process cools the wet channel walls. As these walls cool, they absorb heat from the dry channel air, cooling the air delivered to the building. The portion of air supplied to the building is controlled by a damper that is set for the specific application. This process allows the ClimateWizard to deliver air to the building at a much lower temperature than traditional evaporative systems. This has benefits for both energy consumption and occupant comfort. Delivering 100% outdoor air, the ClimateWizard can improve indoor air quality by increasing ventilation rates to a building. Because it uses indirect evaporative cooling, where the wet channel air cools the dry channel air without any direct contact between the two, ClimateWizard does not add humidity to the building. So, although the system uses water to achieve evaporative cooling, only heat is exchanged and no moisture is added to the building. ClimateWizard is effective in a range of climates and applications, but the energy savings achieved increases as outdoor temperature increases and humidity decreases. So, ClimateWizard is particularly well suited for hot, dry climates. Most of the western United States is suitable for ClimateWizard, and indeed ClimateWizard units have been installed in such places as San Diego, Sacramento, San Francisco, Las Vegas, and Denver. Independent field tests by UC Davis's Western Cooling Efficiency Center and others have shown peak electrical demand reductions up to 60% and energy savings as high as 70%. Of course, total energy savings depends on the specific conditions in which the technology is applied. As with any cooling efficiency strategy, greater savings are possible in buildings with large cooling loads and longer operating schedules. On its website, the manufacturer provides a cooling performance calculator to help determine how much electricity the ClimateWizard might save on a particular building, given its individual characteristics. Depending on the needs of a building, ClimateWizard can work alongside rooftop air conditioners or replace them altogether. With ClimateWizard, 100% of the air delivered to the space is outdoor air with no additional humidity. This makes ClimateWizard an appropriate technology for spaces that require cooling and ventilation air, including those that need relatively dry conditions. Seeley's indirect evaporative technologies, which includes ClimateWizard, have been installed worldwide in wineries, data centers, car dealerships, manufacturing facilities, theaters and recreation spaces, restaurants, university buildings, and more. Hundreds of ClimateWizard units have been installed in California for a diverse range of customers. This video will explain one evaporative cooling product called Munter's Custom EPX. The Munter's EPX is a dedicated outdoor air system, or DOAS, that provides all the conditioning needed for a building's ventilation air supply. It combines compressor-based air conditioning, indirect evaporative cooling, gas heating, and heat recovery all in one unit. Each EPX unit is customized to the particular specifications of a building, but in essence, they all work the same way. Let's take a look inside. There are two air streams that run through the EPX unit. The first airstream supplies ventilation air for the building. It enters the unit from outdoors and passes through the supply air fan. It then passes through the supply side channels of the heat exchanger, the evaporator coil of the refrigerant loop, and the gas furnace. It then enters the building. The second airstream is sourced from the building's exhaust air. From the exhaust fan, the air passes through the exhaust air channels of the heat exchanger and the condenser coil of the refrigerant loop. It is then exhausted outside. The EPX has multiple design features that allow it to minimize energy use while providing ventilation, cooling, and heating. During cooling season, the EPX uses several operating modes in sequence to conserve energy. In ventilation mode, outdoor air is delivered to the space when the building is occupied. As the outdoor air passes through the supply channels, the air is cooled by transferring heat to the building's exhaust air, which is moving through the exhaust air channels of the heat exchanger. This process provides ventilation to the building while efficiently maintaining the indoor temperature. In Stage 1 cooling mode, the indirect evaporative cooling process is activated. The EPX supplies water to the exhaust air channels, increasing the amount of heat transferred between the exhaust and supply air streams. This reduces the temperature of the air supplied to the building. The exhaust and supply air channels allow heat, but not water, to transfer between them. The humidity produced by the evaporative cooling process is exhausted outdoors so that no moisture is added to the building. When evaporative cooling can no longer meet the building's demand for cooling, Stage 2 cooling activates the refrigeration cycle to further increase the cooling capacity. The evaporatively cooled exhaust air is blown over the condenser coil before it is exhausted outdoors. This improves the performance and efficiency of the air conditioning process by reducing the temperature at which heat is rejected by the compressor. In ventilation mode, outdoor air is delivered to the space when the building is occupied. As the outdoor air passes through the supply channels, the air is warmed by transferring heat from the building's exhaust air, which is moving through the exhaust air channels of the heat exchanger. This process provides ventilation to the building while efficiently maintaining the indoor temperature. This heat recovery process contributes significantly to the EPX's annual energy savings. When additional heating is needed, the gas furnace turns on. The setup we described so far utilizes exhaust air to save energy in ventilation, cooling, and heating modes, However, certain buildings are not suitable for this approach. Restaurant kitchens have large heat exhaust loads, making exhaust air unfavorable for evaporative cooling. Industrial buildings that use fume hoods to exhaust building air do not have a centralized exhaust point. To address these limitations, the EPX is designed to provide an alternative installation option that uses outdoor air for the second airstream. Although this setup does not allow heat recovery from the exhaust airstream, the unit still provides efficient cooling by utilizing the evaporative cooling strategies described earlier. Munter's EPX is effective in a range of climates and applications, but the energy savings achieved increases as outdoor temperature increases and humidity decreases. So the EPX is particularly well suited for hot and dry climates. Most of the western United States is suitable for the EPX. Munter's EPX units have been installed in locations such as Santa Clara, San Ramon, Richmond, Chico, San Francisco, Sacramento, Las Vegas, Albuquerque, and Tucson. Independent lab and field tests have verified the performance of the EPX and demonstrated both peak demand reductions and energy savings, and customers report energy savings too. Of course, total energy savings depends on the specific conditions in which the technology is applied. As with any cooling efficiency strategy, greater savings are possible in buildings with large cooling loads and longer operating schedules. As mentioned earlier, higher savings are achieved when the EPX is set up to use the building's exhaust air for heat recovery and evaporative cooling. When installed in appropriate hot-dry climates, Munter's EPX is twice as efficient as a high-efficiency compressor-based cooling strategy that conditions ventilation air and around 20% more efficient than other dedicated outdoor air systems with energy recovery ventilation. A diverse range of customers have installed Munter's EPX in a number of countries throughout the world and in the western United States. Customers include supermarkets, correctional facilities, a commercial printing plant, data centers, an airport, schools, and healthcare facilities.